Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations. Show that the relation R in the set A, set 1, 2, 3, 4, 5, given by R is equal to pair A, comma B, where modulus of A minus B is even, is an equivalence relation. This time, we are given a limited set, set A with 5 elements. And a relation is defined in the set A, which means relation is defined from set A to set A. Domain is set A, codomain is also set A. Any relation from set A to set A is supposed to be a subset of A cross A. A cross A is all possible pairs, all possible ordered pairs made out of the elements of set A. This is what A cross A. Now, a relation is supposed to be a subset of A cross A. This time, the subset is defined this way. Elements of that subset are chosen by using this condition. Any pair A, comma B can be included in the relation only if modulus of A minus B is even. Here, 1, 1, 1, 3, 1, 5. Let's check whether they are in the relation. 1, 1. A is 1, B is 1. 1 minus 1 is 0. Modulus of 0 is even number. 0 is even number. 1, comma 3. 1 minus 3 is minus 2. But its modulus is 2, which is also even. 1, 5. 1 minus 5 is minus 4. Its modulus is 4, which is even. So, we pick up 1, comma 1, 1, comma 3 and 1, comma 5 to be written in the relation in roster form. Are there more? Let's check. Yes. 3, 1, 3, 3, 3, 5. 3, 1, 3, 3, 3, 5. There, these elements difference. The modulus is also even. 3, 1. 3 minus 1 is 2. Modulus is even. 3, 5. 3 minus 5. Minus 2. Its modulus is even. Then, 5, 1, 5, 3, 5, 5. They can also be included with the same reason. Let's go to 2. 2, comma 2 and 2, comma 4. 2, 2 and 2, 4. Because 2, 2, 2 minus 2 is 0. 2, 4, 2 minus 4 is minus 2. Its modulus is even. And these are the elements 2, 4 and 4, 2, 4, 4 also. Only these pairs, these highlighted pairs are picked up to form the subset, to form the relation. According to the given condition, these are the only pairs that can fall in this relation. Now, let us check whether it is a reflexive relation. To call it a reflexive relation, every element of the form A, A should belong to R. Let's see, did we pick up 1, 1, 2, 2, 3, 3, 4, 4, 5, 5? Which are the elements in the form A, A? Is every element related to the same? 1, 1, yes. 2, 2, yes, because 2 minus 2 will be equal to 0, which is even. In fact, for all A, modulus of A minus A will be 0, which is even. So A, A element, all elements of the form A, A will belong to this relation. Hence, this relation is reflexive. Now, is it symmetric relation? Let's check by taking an element A, B in the relation. Suppose A, B is in the relation. Sum AB. It's a representative. This AB may be any of them. It's a general element. It's a representative element among them. And we are going to check this conditional statement. If A, B is there in the relation, we should be able to find b comma a also in the relation. Only then we can call the relation a symmetric relation. So a representative a comma b is taken, which means modulus of a minus b is even. Only then such AB will belong to this relation. Only these two numbers a and b are related when the modulus of a minus b is even. It implies a minus b can be written as twice of m for it to be even, twice of m where m is an integer. If a minus b is 2m, what about b minus a? B minus a will be minus 2m. And if you take the modulus, we find it also an even number. So whenever a pair a comma b is taken in the relation, we will surely find the pair b comma a also in the relation. So this conditional statement, if this present, then this also present, is being satisfied by this general element, the representative element of the relation. Hence we can say the relation is symmetric relation. Next, is it a transitive relation? Transitive relation also satisfies a conditional statement. If pairs of the form A, B and BC are present, then it should imply that the pair A, C also belong to the relation. Let's go by taking representative elements A, B and BC of this relation. A, B and BC, let there be two pairs A, B, BC in this relation, which implies A minus B is 2m and B minus C is 2n. Only then modulus of A minus B is even number. Only then A comma B pair will belong to the relation. Likewise, B minus C is 2n, where m and n are two integers. Now, from these two equations, we would like to eliminate the b, the common element. For that, I am going to add these two equations. A minus b plus b minus c is a minus c on the LHS and 2m plus 2n on the RHS. 2m plus 2n, where m and n are integers, 2 into m plus n is also even. So, modulus of a minus b will be even, which concludes that the pair a comma c will belong to R. So, if there are pairs of this kind, we will be able to find the pair A, C also in the relation. That is logically proved by taking general elements, representative elements of this relation. So, this satisfies the definition of transitivity. This relation is transitive also. Now, a relation R in set A is called equivalence relation only if it is reflexive, symmetric and transitive. We could prove that this given example is reflexive relation, symmetric relation and transitive relation. So it is an equivalence relation. Something more to it.